record on this one.
Got it.
All right, so those of you with questions are welcome to go ahead and ask. I don't know who's going to answer them. So has anybody got problems with some of the facts or sort of theories referred to in this video?
I've got a problem.
Yes, go ahead. Tell us your problem, John.
Oh, sorry, Derek. I got a problem with sound.
Oh, you've got a problem with sound. I thought you had a problem with the video.
No, that was the best video yet.
Yeah. I've got a problem with their attitude to, this. I think basically because of entropy that everything's going to expand to the point of where everything goes dark, even though it might take, I don't know, trillions of years. I'm an optimist and I don't believe that that's the whole story. I believe that, the thing of entropy just going one direction all the time is based on the fact that there is there's a static sort of almost existing amount of material in the universe. And if that is true, then that will happen. But I believe there's stuff being created all the time. Virtual particles popping into existence. And that totally turns that whole thing on its head. Who's got their hand up?
I have my hand up here, Derek.
Okay, go ahead, Elaine.
You asked me something we couldn't understand. Did I hear him say that the universe or the space or whatever it is, now I don't know what it is anymore, but the universe is expanding faster than the speed of light? Or did I mishear?
That one is not difficult to explain. So if you think of it in a, as a two-dimensional surface on a balloon, and you're blowing a balloon up, if you mark spots on the balloon, say at one size, before you carry on blowing it up, you mark spots, say 1 inch or 1 centimeter apart, say all around the balloon. All right, then you blow it up to twice its size, and two adjacent spots will then be 2 centimeters apart. But two spots which are sort of have 2 spots away would then be 4 centimeters apart. And so you extrapolate that to 2 spots very far apart, and they will be a much larger distance, although every 2 spots only was moved an additional centimeter, only doubled their distance away from each other. The furthest spot, it's sort of an additive process. The same with the universe. The whole expansion of the universe is linear almost. And I actually have a problem with them claiming, and I've never understood how they can claim that the universe is, the expansion of the universe is accelerating. They always refer to, yes, at the far distance, at the edge of our, what we can see, things are expanding faster than the speed of light, but that's relative to its distance from us. Its expansion speed, 14 billion light years away is exactly the same as the expansion speed where we are. But it's just because it all adds up over that distance that far spot is moving away, relatively speaking, faster than the speed of light. But it's not moving through space faster than the speed of light. It's the space itself which is expanding relative to where we are faster than the speed of light.
Yeah.
So I don't know if that answers the question.
Partially, because look, I understand what you say about the balloon, but if space itself is expanding faster than the speed of light, then we wouldn't be able to see anywhere. Then the horizon problem would exist everywhere. Like, okay, the Andromeda galaxy, is it moving away from us faster than the speed of light?
The Andromeda galaxy is moving towards us at a speed of, I don't know, like million kilometers an hour or something, quite fast, but it's a fraction of the speed of light moving towards us. It's still going to take 4 billion years to collide with us. So hang on for around for 4 billion years and you'll see the Andromeda. Currently, the Andromeda galaxy is actually 10 times the size of the Milky Way galaxy though. So, but the stars in each galaxy are so far apart. The closest star to us, I think, is what is that one in the Southern Cross, which is 4 million? Is it 4? No, 4 light years away. That's the closest one. And 4 light years is actually an enormous distance. So no two stars are likely to actually collide when the two galaxies pass through each other, but they will distort over a long period of time because of gravity and so on, and relative gravity effects, and so on. But there was actually a talk given by a guy from Botswana who actually explained that very scenario quite nicely, which I happened to have watched this afternoon from the link that Peter sent us from the recording of their talk. And I think you suggested that it might be a good idea to actually invite that guy to give that talk to us. So I think that was put in a very entertaining way, watching that.
Yeah, but Derek, so okay, I chose the Andromeda galaxy, but that was a stupid one to choose because that one. But my question was, did he say that space is expanding faster than the speed of light? Oh, but only at the front.
Yes, space at the edge of our visible universe, relative to us, is expanding faster than speed of light. So yes, that things that we can see now, which are 14 billion light years away, we won't be able to see next year anymore, and we will never see again.
Yeah. Okay, thank you, Dave.
That's only in the periphery of our observable universe.
Yes, only beyond, actually beyond the periphery, yeah.
Yes, right.
So that periphery is continually expanding away from us, yeah. But then he said at one stage in the video, which totally sort of flabbergasted me, he said that is wrong. He made the statement there that it is wrong that space is expanding. So I'd have to go back.
There's more space in between.
No, but I don't know. He just said that whole view.
He said that space came in the middle. They weren't expanding. It's just that there was more space in front of them.
Yeah.
That's why between us and another galaxy, that distance we can see and we can measure is getting closer or not to the limit of vision. Yeah, those stars that pop over your limit of the observable universe, they don't necessarily destroy or anything. They've gone out of vision. That's all.
Yeah.
So we can go on ad infinitum.
Yeah. So my feeling is that, James Webb is bringing up new stuff all the time. They're finding full-size galaxies bigger than they should be according to the theory of the Big Bang, which are much older than they should be at the size that they are, this sort of thing. I don't know. They're also coming up with explanations of why they're finding this, trying to sort of rescue the Big Bang theory almost. But, I wonder personally, I've got a strong gut feel that the universe always was the size it is, and it always was expanding, and there's always new stuff being created, which is filling up that expansion, creating more stuff. I just think it's going to carry on. So I'll hang around for about 5 trillion years and see if I'm right or not.
Yeah, Fred Hoyle, he maintained a continuous universe, continue.
Yeah. So interesting actually. In this, they mentioned this guy Gödel actually towards the end of the universe, and that's this whole book I'm reading is about that section of about 2 minutes that he described there, and described this rotating theoretical universe that he came up with. But what they say in this book is that what that proved to him was that time doesn't exist. So I wasn't able to find where he logically comes to that conclusion and how he comes to that conclusion. But I was quite desperate to find that, but I couldn't find it. I don't know, unless, yeah. But anyway, yeah, my view is that time is, I like the way he said that space and time are emergent phenomena. You know, that gels with what my feeling is, the way things work. But my feeling is that time is just an abstract concept which humans have to make sense of the world around them. Peter put me on to a thing called Quora. They send emails with interesting questions that people ask, and then people answer them, tell them why they're talking rubbish and so on. and one of the, there was just a thing with a riddle. I think it was in that one of those emails where the people said, what is always approaching you but never reaches you? And the answer was tomorrow. Because when it reaches you, it's the present and it's not tomorrow anymore. So it's now, not tomorrow. Anyway, yeah, so time, it's just the way we got to think. I mean, what is time? You know, it's, I always say, how do you measure time? You know, you always measure it in units of sometimes length. It's the relative change in position of one object relative to the change in position of another object. There's no other way to measure time. So what is it really? It's really just a change in relative position of two objects. And you're calling the amount of time it takes, you giving it a time unit. You know, like the Earth rotates at the moment, that is. At its current stage of life, the Earth rotates once every 24 hours. It never used to. It used to rotate much faster. But it's losing a second every few hundred years or something. So it's slowing down quite rapidly. At least a second every few hundred years. Yeah.
You just proved the point of time. Time is an arrow moving forward, because you said, as you know, the answer was tomorrow, because tomorrow then becomes the present. Obviously, you cannot ever go back because you can't undo something that's happened.
But the present doesn't exist. The present is always instantly becoming the past. The future is always instantly becoming the present, which is always
tell
becoming
that to
the
the
past.
traffic cop who stopped you speeding. Yeah.
So if I say now is the past, because I said it just now.
Yes, absolutely. That is the past.
Yeah,
I mean, if you
it's
look
all
back,
very confusing.
you look back to the people in years ago when they didn't have clocks. Time was measured by the sunrise coming up and going down, Stonehenge and all that sort of stuff.
Yeah.
They measured the passing of time. They didn't look forward to it. They could only look back. If you're watching the sunrise over the Anvil Stone at Stonehenge, you only see what's happened just instant behind. Your future is you guessing, looking forward, it's going to come up. And then it does. And you say, I looked ahead, didn't I? We're just getting fussy about the accuracy of measurement.
Yeah, so we've got to, in order to survive, we've got to be able to predict speeds of objects moving. So we've got to be able to, if you're a lion, you've got to predict the speed that buck is running at, and what time it's going to get past that rock that you're standing on and that you're going to jump onto it from.
That's right.
Or whatever. So it's evolution almost. The perception of time is a requirement of evolution.
Yes.
But it's a perception. There isn't a thing that you can go and buy off the shelf in a shop in a box, which you open it up and you look inside and you'll see some time. There isn't anything like that. Doesn't exist.
Yeah.
Okay. If we're all agreed that time doesn't exist, then we can stop.
Time to go for a drink.
Yeah, I think so. Definitely a good big glass of red wine. But Derek,
Yeah.
before we all go, I spoke to Harold Hester, who gave the presentation the other day, and
Did
I have
you?
his contact details. And if you would like, he's very keen to give it again to a group like ours. Okay, so it could be the subject of one of our monthly things at Onrus Manor, and he would be very pleased to present it via Teams, I think, rather than Zoom.
Yeah. I don't like Teams, but anyway, if he prefers that, that's fine. But I see he had the
Okay.
same problem I had the last time in a Zoom meeting where I was putting up slides and the whole slide could be seen on my computer screen, but when it's displayed by Zoom, then the edges are chopped off. So well,
And
I'll have a chat with him before the time and see if there's a way to get around that, because he had text on the edge of his slides, which you could guess because of what he was talking about, what the text said. But it is a little bit
send you
annoying.
his contact? I'll send you his contact details, Derek, and
Thanks.
maybe you could have a chat.
Yeah,
Okay,
because
good.
I had the same problem, so I'd like to be able to try and sort that out. I think
Okay,
maybe
good.
if you give your presentation as a PowerPoint with PowerPoint slides, and maybe they will fit inside the screen without bleeding off the edge.
Sure, I'm sure he has done.
I'll try that. I'll try various things before, and just as a.
Okay. Thank you, Derek.
But thanks for sending that. I found it. He spoke what he was doing really, just talking about the scale of the universe. Essentially, when he was talking about, it was also about time, but it was about light years and relative and this, what the scale of a light year is really. That was quite interesting to bring things into perspective, and he did it in a very entertaining way. So I really liked that.
Oh, good, excellent. I'll tell him. He never gets feedback after a presentation on Zoom, so I was very pleased to get a communication from me.
Yeah, I was rather disappointed in the recording when he ended and asked for questions. Nobody seemed to have questions.
Yeah,
I don't know if you had a big audience.
Okay, good. Thank you, Derek.
All right. Yeah, I'd just like to make one comment again. I think the whole thing of entropy, I'd just like to repeat that. I think it's wrong. I think it's wrong to you're talking about a static universe if you're talking about entropy essentially going in one direction and ending. I think
Derek, I'm an engineer and I know how a steam engine works. And entropy, it very much depends on entropy.
Yes, it is true. But then you're working with a limited amount of. By the way, I think he also made an error when he was saying that whole thing of the electrons colliding. If you reverse the movie, you won't be able to tell the difference. I think that is from an engineering point of view. Exactly. I think that is very, very incorrect. Because if you have, it's a sort of an elastic effect. Two like charges will repel. So if they're traveling at a speed towards each other and then bouncing back off, there will be an energy loss in that bouncing. Never mind if it's at the atomic scale and it's electrons, there will still be some kind of energy loss. So the bouncing back will never be at the same velocity as the approaching velocity. So you will definitely be able to tell and measure the difference between the film being reversed and played normal direction. So I think he was wrong in that one.
Okay, interesting, dude. Thank you.
Based. All right, that's a bit of a Newtonian approach, maybe not, but still, I think it's valid. And I think a lot of I think he pulled together all the conventional views very well. There is just one thing. I sent it to Peter, and I think Pierre as well. Pierre told me this morning he hadn't read the document. I just want to quickly call it up. If everybody's still here, I just want to share that quickly.
We've only got 4 people at the moment.
Right, but I just quickly, let's see if I can find it. What actually is space of time? All right, no, all right, but I'll just tell you what it is quickly. There was a guy that I think it was in another thing called Medium, another which sends emails about science questions and physics and so on, astrophysics, and discusses it. And this guy came up with a theory that that the Schwarzschild representation of the event horizon on a black hole is incorrect. It's a sort of a classical formula, and it doesn't take into account time dilation, which is very much has to be taken into account at a black hole, because that is actually what a black hole is about. And if he slots time dilation into the formulas, then you get a so-called event horizon which is much smaller than the Schwarzschild event horizon. And he reckoned this has been proved by observation, by that image of the black hole that they took with that sort of global wide telescope around the whole Earth. Because I mean, you must read that article. I found it really fascinating. Then I searched for him online because I was worried that he was a pseudoscience, but he's actually a qualified astrophysicist, got a doctorate in astrophysics and physics and mathematics and stuff. And there was no review which said, no, this is rubbish or anything. And he has also written a book which is in a PDF form and free to download. And I think I sent that link to Peter. If Peter's still there, I can't remember. But I'm going to go through that book because that looks really fascinating. And I think it just makes so much sense to me. I always had a problem with this thing that time is supposed to stop when you reach the event horizon. You know, if time stops, how can you fall into the black hole? It just never made sense to me. And the way he explains it, it all makes sense. So I think if we're at some stage, that might be a nice one to discuss as a sort of in-between session. All right. That's also all linked to time, of course, yeah, to tonight's session. All right. Anybody else with comments and questions that before we log off? We just got 2 people left, I think. Just you and me, John. Everybody else gone.
Yeah, I can hear everyone's buggered off. I still think this one you found was the best one yet. I do enjoy that. There's things that I would question him on. You know, when he said he was talking about space expanding, you know, and you're talking about nothing getting bigger, and that is, it's difficult to get your hand around it. But if you can get your hand around it, great stuff.
If I may just ask.
Okay. Yep. Go ahead, Peter.
This business, and I've always had a problem with this one. This business of space itself is expanding. Now you have a meter rod. Is that expanding?
No, it isn't. I'm pretty sure it's not. I don't know. Maybe it is.
The meter rod is not expanding, but space itself is expanding. So why isn't the meter rod expanding? And the ball next to it, which you say 1 meter in diameter, that's not expanding then.
Yeah.
Relative to who?
You see, it makes that sentence totally meaningless.
Yeah, Peter, now you try and get a physicist who's lecturing you and telling you that space is expanding to admit that the rod is not expanding. Try and get him to explain that. He'll avoid the question, I'm pretty sure.
Absolutely, because it's a meaningless sentence to me.
Yeah.
Well, then,
anyway, I think it's getting late now, guys.
Yeah, I think it was quite an interesting session, and let's stop the recording there.